Here's your video example for Chapter 4. Chapter 4 is all about displaying quantitative data. So in this example, I'm going to teach you guys how to make a histogram. Now, a histogram is very similar to a bar chart, right? But bar charts are for categorical data and histograms are for quantitative. Now, the difference between a histogram and a bar chart, besides quantitative versus categorical, is that on a histogram, the x-axis is a range of values, and your y-axis is the frequency of those values. So what we do for a histogram is we look at our data, and my data here is for bird species. It says the Cornell Lab of Ornithology holds an annual Christmas bird count in which bird watchers at various locations around the country see how many different species of birds they can spot. Here are some of the counts reported from sites in Texas during the 1999 event. So these are the counts, right here, there's 21, of how many bird species they spotted. Now if I look at my range of values, it looks like it goes from 152 to 228. Instead of marking down all of these values separately, what we do is we put them into what we call bins. And bins are basically a range of numbers. For a histogram, ideally, we like between 5 and 20 bins. So what I did, and you can already see it to the side of here, is I looked and I said, okay, 152 to 228. So the easiest way I thought to separate these would be to go by tens, and just to make it nicer, to start at 150 and just go up by tens. So since my data ranges from 152 to 228, I need to go from 150 to 230. That gives me 8 bins. What I then do is I see how many numbers fall in between these two values. Now here's what you need to be careful of. Well, 150 to 160 are here. Here's 160 to 170. You can't count the 160 twice. It needs to go in one bin or the other. What we do with the highest number, so the 160, goes in the bin below it. So technically what we're really looking at in this first bin is the values 150 to 159. So here would be 160 to 169. Here would be 170 to 179. So that upper edge goes into the bin above it, or the next highest bin. So I'm just going to start looking for my data values. So 150 to 160. So I look, I see 152, 153, 153, 156, 157. I look around, I see 160, but I'm not going to use that because that's the upper edge, so it goes in the bin after it. So there's 1, 2, 3, 4, 5 values that are between 150 and 160. So then I go to the next one. I have 160, 160, 162, 167, 162, 166, 163. So here, that's 7 data values. So then I go to 170 to 180. So I've got 178, 177, 175. So that's 3. Then I go to 180 to 190. So 186, 183, 181. So that's another 3. Then I go to 190 to 200. Well, none of these left over are between there. So that's a 0. 200 to 210, I have a 206 and another 206. So that's 2 values. 210 to 220, I don't see any. And then 220 to 230, I have 228, so I have one value. So like I said before, there were 21 values total, so make sure these add up to 21, which they do. Now that I have my bins, right, and how many values go in each bin, I need to create my histogram. Now, I've already labeled some of this for us, but the x-axis is going to be the number of bird species. So notice how each bin, I didn't write 150 to 160. Since I'm going up by tens, I just went up by tens. Okay. The other difference between a histogram and a bar chart is unless there's actually gaps in the data, your histogram, your bars should touch each other. So any graph that we do here, you need to label. So I'm going to label my x-axis as bird species. And my y-axis, it's going to be too hard for me to label this on the side, but my y-axis I would call frequency, because we're counting how many go in each of those bins. So that would normally go on the side of my y-axis. I just don't have room. So now I'm going to make my bars. So again, bear with me because I'm doing this on the computer, so it might not look great. But from 150 to 160, we had 5 data values. So I'd go to 5. There's 150 to 160. Then from 160 to 170, we had 7 values. So I go up to 7. Then from 170 to 180, we had 3 data values. From 180 to 190, we also had 3 data values. From 190 to 200, we had 0, so this would be a gap. From 200 to 210, we had 2. From 210 to 220, we had 0, so that's another gap. And then from 220 to 230, we had 1. So besides my lines being horribly crooked, okay, that would be my histogram. Now this problem also asked us to describe the distribution. So now that you've kind of gone through this chapter, you've read the chapter, you should have seen that we describe distributions using 4 things: shape, center, spread, and outliers or unusual features. So if I look at the shape of this, I would say that it's unimodal because it has one clear highest value from 160 to 170. So it's unimodal and skewed to the right. So if I were to draw just a gentle curve over this, right, it tails off on the right side. Wherever we have our tail, that's where the skew is. So when I write this out, everything has to be written in context. So this distribution, we're talking about the number of bird species. So when I write this, I'm going to say the distribution of bird species spotted is unimodal and skewed to the right. And I'm going to talk about the center. Okay? The center looks like it's probably around, so we're like the middle 50%, or would be around 160 to 170 birds. So I said the center of the distribution is around 160 to 170 bird species. The spread is the range. So our data ranges from 150 species spotted to 230 species spotted. Then I'm going to talk about unusual features. Now, there's no major unusual features or outliers, things that don't match our data, but there are some gaps. So that's what I'm going to talk about. There are gaps in our distribution around 190 to 200 and 210 to 220 bird species. So that is me describing my distribution. I talked about the shape, the center, the spread, and outliers or unusual features. So that is the Chapter 4 video example. Again, this chapter is all about quantitative data and displaying it.